In February 2024, SpaceX announced that it would begin a controlled descent of 100 of its old Starlink version 1 satellites over the coming months. It would lower them to orbits where Earth's gravity could finish the job, pulling them into the atmosphere where they would burn up on re-entry. This decision was made in response to a potential design defect that could result in satellite failures, preventing them from maneuvering. Deorbiting these satellites mitigates the risk of generating space debris and guarantees more sustainable uses for low Earth orbit. This process is helping the U.S. Space Force gather crucial data and real-world experience for itself. Since May 2024, Space Force's Space, a unit of the Space Force representing U.S. Space Command, has been publishing on social media various satellites, rockets, and debris it tracks as they enter the atmosphere. But while this work has been ongoing for years, the difference now is that SpaceX is not passively waiting for its spacecraft to decay or fall from space, but is actively working to ensure their demise. The U.S. Space Force's 18th Space Defense Squadron tracks the orbits of spacecraft and debris and issues warnings when there is a risk of collision so that satellite operators can maneuver to avoid them. However, tracking deorbiting satellites also gives space operators a chance to practice space domain awareness with real events, said retired Air Force Colonel Jennifer Reeve, Senior Space Research Fellow at the Mitchell Institute for Aerospace Studies, in an interview with Air and Space Forces magazine. Reeve labeled the partnership between SpaceX and the Space Force as an extraordinary opportunity. He elaborated that it enables the Space Force to comprehend SpaceX's predictions for satellite re-entry by factoring in their deliberate deorbiting maneuvers. During these events, Reeve observed that this collaboration offers immediate feedback on the actual detections of military sensors. The retired operator underscored the significance of this procedure in verifying the capabilities of their sensors. He noted that it verifies the sensor's capacity to detect deorbiting events with precision and assists in identifying potential variations between different occurrences. Reeve also clarified that the Space Surveillance Network, which includes ground and space-based sensors, will monitor these deorbiting events. He stated that this tracking procedure offers Guardians an opportunity to enhance their abilities through valuable practice. Reeve emphasized the urgency of these endeavors, stating that the Space Force is in the early phases of comprehending the appearance of numerous deorbiting events within the organization's sensor and reporting network. The expansion of so-called mega-constellations in space, involving thousands of small satellites in low Earth orbit, will require satellites to be deorbited as they age. There are over 5,000 Starlink satellites alone, and other companies are deploying or developing constellations of similar size. The Space Development Agency of the Space Force plans the proliferated warfighter space architecture, consisting of hundreds of satellites in low Earth orbit. The Federal Communications Commission has implemented a rule requiring commercial operators to deorbit their satellites within 5 years of the satellite's completion. Thus, all satellites launched into space will eventually need to be deorbited. Reeve said lessons learned from events involving growing clusters of satellites in low Earth orbit will apply to everyone, including the Space Force. The Space Force will also be able to use deorbits to refine missile warning skills. Satellites re-entering the atmosphere will also have their own infrared signatures, like the infrared signatures of missile launches. Reeve emphasized the importance of real-world training for new personnel. He explained that the appearance of radar data on an actual console differs from simulations, though he acknowledged that, at times, the distinction can be subtle. Reeve highlighted the value of using authentic data for training purposes. He described the current situation as an ideal opportunity to practice with real-world information rather than relying solely on simulated scenarios. The veteran operator stressed the need for comprehensive training that goes beyond equipment familiarization. Reeve emphasized the importance of testing both the equipment and the observational skills of young operators. He noted that while operators are generally well-trained, additional practice is always beneficial in honing their ability to identify and interpret radar signatures accurately. SpaceX controls the deorbiting of these older satellites, which entails using onboard propulsion systems to reduce their orbits. Once in a lower orbit, the natural attraction of Earth's atmosphere reduces the risk of debris reaching Earth, resulting in their combustion upon re-entry. SpaceX's Starlink satellites are designed to be completely demisable by design. This implies that they are designed to disintegrate entirely upon re-entry, further minimizing debris danger. As newer, more sophisticated models replace older ones, SpaceX will likely continue to deorbit them with subsequent Starlink launches. Do you think deorbiting and not ejecting satellites into deep space is the safest way to destroy satellites? We bring you some good information on aerospace. Please like and share the video and subscribe the channel.